This sample will help you calculate things related to the potential energy held by a spring or a rubber band or a bungee cord or something like that. The example that I gave in class, I'm going to do for you here. We have a bow and arrow, and the reason you can fire an arrow from a bow's string is that that string is stretched, which stores some potential energy. So the formula that we have for spring potential energy is 1/2 kx squared. So let's talk about what those quantities mean. K is what we call in physics a spring constant. It's a quantitative, it's a number measure of how stiff a spring is. So if you have a really loose spring that's easy to stretch and compress, it will have a low spring constant. A tighter spring, one that's more difficult to compress, like the shocks on a car or a very stiff spring on your garage door, is going to have a high spring constant. Now, the units for that are newtons per meter. Make sure you write that down because it's nowhere in your book. It just basically says how much force do you have to apply to a spring in order to stretch it or compress it by 1 meter. So that's one variable in this kind of problem. The other one is x. And so the x is not the length of the spring, okay? It's not the length of the spring or bungee cord or whatever. It's the amount that the spring is stretched or compressed. Okay, so what you'll see here, sorry, that's messy writing, is you'll say, okay, well, here's a spring at its normal length. Well, what if I compress it? How much is it compressed? Or if I stretch it, and this was the normal length, how much does it stretch? So that's our variable x here. So when you see a problem, it'll say the spring is stretched by this much or compressed by this much. It might give you the relaxed length and tell you what its final length. So you might have to add or subtract, but I'll try to keep the problem simple for you guys. Now, one thing to look out for is that since x is a distance, it needs to be in meters. And sometimes when we're talking about a bow and arrow or a stapler spring, we're not stretching or compressing that spring by meters. We might use centimeters or even millimeters. So be careful, just convert that number back to meters and you should be fine. So the example that we had in class said that the bow and arrow had a spring constant, that's our K, of 50 newtons per meter. Then it says if you stretch the bow 60 centimeters, how much energy will the arrow have? Okay, so our X then is 60 centimeters. But like I said before, we've got to convert that to meters. So we divide by 100 and we get 0.60 meters. Nothing more difficult than that. So then our potential energy is equal to 1/2 kx squared. So let's put our numbers in here. 50 newtons per meter. And then we have 0.60 meters, but we have to square that. So we'll put it in there twice. Now, a couple of clicks in your calculator give you 9 for your answer. Again, the unit for potential energy is joules, but let me show you how we get that. This meter cancels out with that meter, but we're still left with a Newton times a meter, which equals a joule. So our answer there is 9 joules. And this is useful because, like we'll see in section 4, we can calculate how fast the arrow is going if we know the mass of the arrow. So knowing how much energy is held by that system is helpful. Now let's go ahead and unpack this formula, 1/2 kx squared. What if you're looking for k? Right? Well, what I need to do to get k by itself, I need to multiply both sides by 2. That gets rid of my half. So now I have 2pe equals kx squared. So I'd have k equals 2 times the potential energy over x squared. So you could do that with just one calculator stroke. The x squared in the denominator shouldn't mess things up. What if you need to solve for x? Well, same thing. I need to multiply by 2 to get rid of the 1/2. Now I need to divide by k to get rid of that. And then take the square root of both sides to find x, right? That's a couple of extra steps there. So what you would do then is I would multiply 2 times the potential energy, divide by K, then take the square root of that whole thing, and you can get your answer. So make sure that you have all of those formulas in your notes and come back to this sample if you need more help.